Hi guys. So this lesson is going to put together all of the transformations that we've learned so far in Unit 3C and look at the order in which we should be using them in order to enact changes on a parent function. So we're going to look at this as vertical transformations separate from horizontal transformations because they work slightly differently. So up at the top, we have combining multiple vertical transformations. So when you combine multiple vertical transformations, it's important to apply them in the correct order. So for vertical transformations, we follow the order of PEMDAS. So there are different transformations that are done vertically. So we have reflection, stretches, and shrinks, and those are all multiplication, and that looks like k times f of x. If you have a shift, that's going to be an addition or subtraction on the end of the function. So what we're looking at here is anything that's multiplied happens first. Anything that's added or subtracted happens second. And vertical transformations all happen to the y value. So these enact change on y values. Now, horizontal transformations are anything that's happened inside the groupings or the parentheses. So these actually, all of these occur opposite of what you'd expect them to do. So you have different transformations like f of x plus k or f of x minus k. And we know that if you're adding k, what you're actually doing is you are moving to the left k units. If you're subtracting k, you're moving to the right k units. The other piece that happens here is you could have f of kx or f of negative x. Now, if you have, this is called a horizontal dilation. Remember, if you are dilating by a scale factor of k, what you're actually doing is you're going to divide by the k values. So again, horizontal transformation, anything that happens inside the parentheses is happening opposite of what you think it's going to happen. So for this reason, when you combine multiple horizontal transformations, you have to apply them in order. And because they happen opposite of what we expect, this holds true for the order as well. So the order of operations is reversed. So we're going to start with addition and subtraction and move to multiplication and division second. So keep in mind, horizontal transformations change the x values. So I'm going to go through two different examples with you just to solidify this concept. So when I do multiple transformations, I always start with my parent function table. So I'm going to do that here. So in example 1, I have negative 3x squared plus 5. Now the first thing that I'm going to do is I'm going to make my parent function. So if I have x squared, I'm going to go negative 2, negative 1, 0, 1, 2. And I'm going to have 4, 1, 0, 1, 4. That's the parent function of x squared. Now, there are different things happening here. Notice there are no parentheses. So actually, this can confirm that my x values are going to stay the same always. So I'm going to do two different things, but my x values are not going to change. The two different things I need to do is I need to multiply by negative 3 and I need to add 5. Since these are on the outside of groupings and parentheses, they happen exactly as is. So since the x's don't change, there's nothing happening in here. I can still keep negative 2, negative 1, 0, 1, 2 in both of my next tables. So between multiply and add, the first thing that's going to happen is I'm going to multiply by negative 3. Because since it's happening vertically, it's order of operations. So multiplication comes before addition and subtraction. So 4 times negative 3 is going to be negative 12. 1 times negative 3 is going to be negative 3. 0 times negative 3 is 0. 1 times negative 3 is negative 3. And 4 times negative 3 is negative 12. Now my next step is to add 5. So first I multiplied by negative 3. Now I need to add 5. So I take this set. So these are all happening in order. So multiply by negative 3. Now this is my new function, and I'm going to add 5. So negative 12 plus 5 is negative 7. Negative 3 plus 5 is 2. And then I have 5, 2, negative 7. So now, just so that I can see this clearly, I am going to plot my parent function in red. So negative 2 comma 4. Excuse the sirens in the background. Here is my parent function. So now I'm going to take my new function and I'm going to plot it in blue. So I have negative 2, negative 7, negative 1, 2, 0, 5, 1, 2, 2, negative 7. So notice this is flipped upside down, which makes sense because I had a negative in here. I just chose to do that with the 3 because they're doing the exact, I'm multiplying both of them. So I flipped upside down, it's shifted up 5, which is good, and it is vertically stretched. So notice this is stretched out compared to the original red function. All right, so I'm going to look at number 2 now. So number 2 is also a quadratic. So I can plot that same original function in here. And I can use the same original table. So now I want to look at the different things that I need to do to this function. So I notice I have stuff inside the parentheses now. So I notice that I'm going to now on the inside, these act opposite, but they happen to the x values. So with the x values, I need to do 2 things. This is multiplied by 2, so I need to divide by 2. And this is minus 6, so I need to add 6. Now, which one's going to happen first? Because it's on the inside and it works opposite, addition is going to happen before division. Now, this here is happening to the y value because it's on the outside. So I'm going to subtract 8 because on the outside I do the exact same thing that it looks like. All right, so the first thing I'm going to do, I can do something to the x values and the y values at the same time because I don't need to use order of operations for that. So the x values, I'm looking at these x values, and the first thing I'm going to do is I'm going to add 6 to them. So negative 2 plus 6 is 4. Negative 1 plus 6 is 5. 0 plus 6 is 6. 1 plus 6 is 7. 2 plus 6 is 8. So now I have done this part. Now with the y's, I can also do minus 8 to the y's. So I'm looking at the original y's. If I subtract 8, I have negative 4, negative 7, negative 8, negative 7, negative 4. So I've also done this now. So now the only thing left to do is take the x values and divide them by 2. So I've already done everything I need to do to the y, so I can keep those. Negative 4, negative 7, negative 8, negative 7, negative 4. Now I'm going to look at the x values and I'm going to divide them by 2. So 4 divided by 2 is going to be 2. 5 divided by 2 is 2.5. 6 divided by 2 is 3. 7 divided by 2 is 3.5. 8 divided by 2 is 4. So now I'm going to plot these points. Now what I should see is a shift right 6, down 8, but then I should see a horizontal shrink by a scale factor of 2. So let's see what happens. 2, -4. 2.5, -7. 3, -8. 3.5, -7. And 4, -4. So if I combine these, make my nice line, notice it is shrunk. One thing to keep in mind, I know I said I was going to move right 6, but after I moved right 6, I needed to divide by 2, which actually moved that in. So with order of operations, we haven't actually looked at one that has a coefficient of x on the inside. So that changes the idea of where the vertex is. It has shifted down 8, and that y value didn't change. So I did shift right and down, but then this horizontal shrink pushed it in towards the y-axis. So this just goes to show how important it is to understand the order of operations when you're doing the transformations. So just a reminder, vertical transformations are anything that happens on the outside of grouping symbols. So this -3, this 5, and this -8. And whenever you have vertical transformations, these follow order of operations. Anything that happens on the inside is happening to the x values. And this is a horizontal transformation. So that's this 2 and this 6. Now, anything on the inside happens opposite of what you think, or opposite of what it appears. So the order of operations is reversed. So you start with the addition and subtraction, and you move to the multiplication and division. You need to make sure you do those in 2 different steps.